Hey everyone, welcome! I'm super excited to kick off this new series where we'll be exploring how to build decentralized applications, or dApps, using Cartesi and Python. In this series, we're going to break things down step by step. If you're looking to expand your skill set, there is something for you here. We'll start with the basic, creating your dApp and running it, and then dive into key features of Cartesi to work all your way up to building functional dApps. The way this is going to work is each episode will cover a new concept, from how to create, run, and build your Cartesi dApps, send inputs, handling assets, all the way to deploying. By the end of the series, you'll have a solid foundation to build cool solutions. That is, if the series ever ends. I don't know, it might go on forever, so let's just get started. So, how do you create your first project? You can use the command Cartesi create. This will create your app. Simple, very simple. And if you look at its directory, you have a Docker file, the dApp code, a README, and the requirements for you to install any libs that will be built on your dApp. Remember, to start building, you will have to have your Docker desktop installed and running. So once we have all this set up, you can just run Cartesi build. Now we can just open the code in Visual Studio Code. And you can check our dApp. It's actually built and we can run it. To run it, we're gonna just use Cartesi run. Okay, so my Cartesi dApp is running. I get some endpoints for tools that are gonna be really useful later, but I'm gonna just demonstrate the very basic for you at first. For this, I'm gonna open another terminal window inside Visual Studio Code. Here, inside my folder, I'm gonna perform a Cartesi send. I'll pick the kind of input that I want to send to my dApp. In this case, a generic input to the Foundry blockchain that's running locally here. And I'll select all the first options. And I'm gonna send a string written hello world. Okay, so if we check our terminal now, you can see that I received a message, received advanced request data, message sender, so who's the specific sender, with index of the input, timestamp of when this input was sent, and the payload. The payload is essentially the message that I sent. So let's go to a hex to string website to see what's written here. This is a hex to string converter. I can paste my hex here and see that hello world actually arrived in my application. Where did that happen exactly? How did this happen exactly? Well, the Cartesi framework has some group of smart contracts pre-deployed on-chain. In this case, I'm sending a message to a smart contract called input box. And then the Cartesi node, which is running on my machine together with the Founder blockchain, is subscribing to this smart contract. My node is subscribing to the smart contract and watching whenever an input arrives there. Once an input arrives there, directed towards my dApp for its address, I actually trigger this function right here, handle advance. That is why this message here appeared, received advanced request data. But how can we pick this data? How can we interpret it and mess with it and change it? That's the content of this first video. It's pretty simple, pretty straightforward. We're just gonna get the payload, print it on your screen so you can understand how to receive inputs from the blockchain with no issues. As you can see, the payload that arrived here is in hex format. So we're gonna need a function to translate this from hex format to the string format. So you, as a developer, can actually mess with the data. Okay, let's understand what exactly I did here. I opened the data object. As you can see, this is the format where the data arrived. Got the message sender, which is the author of the message, and I added it to a print command saying that this sender is saying the message, then the content of the message translated from hex to string. That means I can actually see and print the clear data value that was actually sent by the user. Now that we did that, let's stop the application so we can rebuild it. The application was stopped. You can even check this on your Docker desktop dashboard. And now let's rebuild it because we made some changes. All right, application running. My changes are working now, and I can run again Cartesi send command. generic, foundry, mnemonic. I'll pick the first user here and send hello from the first user. I'm going to be sending this input, and this input will be printed here because of this print command. So the first user says hello from the first user. What if we send from another user? We can use the Cartesi send command. And let's send it from this user here. Now I got to print from the second user. You can see that it's another address. It's different from the first one. And it says hello from the second user. So this is it, how I can actually get my data, parse it back to a string, and do whatever I want with it later. An idea if you have to send more structured data to add separators or send a JSON format or any other format that you think is more performant and ideal for your application. But this is basically how you send data to the Cartesi machine. Now, you have to understand that when we are doing this Cartesi send here, it's basically an abstraction of a transaction being sent through a JSON RPC call. That's why I put a mnemonic there and select the user that is sending, because these addresses are all addresses that are created and filled with assets in the local network that I'm running the app. Another way to send inputs is through the Cartesi Explorer right here. In the Explorer, in my applications, you can actually see that there's a list of inputs from things that I sent. There is this input, hello from first user, hello from second user. You can see who's the sender right here. Then you can check a list of every input sent to the blockchain. Now, what I'm going to do is I'm going to connect a wallet, which I call Alice. I'm already connected on localhost, and just to be sure things will work fine, I'm going to clear the activity data tab, so I'm clearing any kind of cache that exists. And I can send now a transaction. This transaction can be an Ether deposit, an ERC20 deposit, or any other thing. All of these kinds of transactions will be arriving at the handle advance function right here, this endpoint. So what I'm going to pick is a raw input, select this application as destination. This is the full that address for when you're running locally. And as an input, I'm going to send I love Cartesi. So this is the hex content. I'm sending it here. I'm going to send, and I'm going to sign a transaction. As you can see, Bob, the user, is actually signing the transaction. So I said I was going to send it with Alice, right? So I have to disconnect here, connect wallet. Okay, now I'm connected with Alice. Send transaction, once again, raw input, the application, and the content. Now you see, I'm gonna sign a transaction, and this transaction will go to the input box contract and will trigger processing in my application. I just received here, Alice user says, I love Cartesi. And that's it. This is how you send inputs to your dApp and you decode them with Python. You can refresh here and you're gonna see that the content was sent to your application in the Explorer as well. That's awesome, guys. That's it for the first video. Thank you a lot for your attention. And in the next video, let's talk a little bit about outputs. Okay?